Okay, this is ASFurther Maths. We are doing chapter 4 vectors, and we're looking then at the scalar product, also known then as a dot product. It's basically a good way of finding an angle in between two vectors. So the scalar product of two vectors A and B is defined as the product of the magnitude of the two vectors multiplied by the cosine of the angle between the two vectors. So A dot B is generally how you would call it, is equal to magnitude of A times magnitude of B times cos theta. Some way then you might want to see it, you sometimes see it then written as A dot B equals then x1 x2 plus y1 y2, so that's in two dimensions. So you multiply the number beside the I in the first one by the second one, and add it number beside the j in the first one and the second one. So you can kind of see in the examples, it'll make more sense whenever you actually see the examples done. When two vectors are perpendicular, their dot product is 0. So if you have A dot B, it's going to be cos of 90, and of course cos of 90 is 0. So two perpendicular vectors and their dot product is going to be 0. For two parallel vectors, if they're parallel to each other, then they're effectively kind of the same thing. That's why we would write this one then as A dot A. So that's equal to then magnitude or modulus of A, magnitude of A, cos of 0, and of course cos of 0 doesn't give us 0, it gives us 1, so that means you're going to have cos of A squared, and that then would just give us A squared. This is really a better example. Whenever you see it actually with actual numbers, it will make a wee bit more sense. So what are we going to have to do? We're going to try and find the angle length between the two vectors. So our formula for a dot product is A dot B equals magnitude of A times magnitude of B cos theta. To work out A dot B, we'll go the slow way here just to kind of show you how it works, but the sums are really easy. But what you're doing effectively is multiplying each thing by each thing. So if we do A dot B, that's really going 3i plus 4j multiplied by 5i minus 12j. So what does that give us? That gives us 3i times 5i, so 3i dot 5i, that's our first outer, 3i dot minus 12j inner, 4j dot 5i, that's last, 4j dot minus 12j. So what's going to happen here? See this ij one? Those two then are perpendicular to each other, and if they're perpendicular to each other, their dot product is 0. So the dot product of that is 0. The dot product of that is 0. All you're left with then is the A. So you go 3 times 5, which is the 15. 4 times minus 12 minus 48. So A dot B in this case is minus 33. That all you really do in any of these things, whenever you're trying to work out the dot product, you don't need to go through this whole big rigmarole, but you just do 3 times 5, 15, take away 48, and so the dot product then is minus 33. What else do we need for then this formula? We're trying to work out the angle, so we need to work out our cos theta, we need to work out the modulus of A, modulus of B, so we know how to do that. So if I go down here, of A, that's the square root of 3 squared plus 4 squared. That's going to give us 5. For B, it's 5 squared plus minus 12 squared. and that's a Pythagorean triple as well, so it works out quite nicely, and it's going to be 13. So substituting everything in then to the formula, we're going to get minus 33, because that's the A dot B, equals 5 upon 13 cos theta. That means cos theta is minus 33 over 65, and if you put that into your calculator, you get about 121 degrees, and that's the 3 significant figures. We won't actually find the angle between these two vectors here, but I hope you can see this is just the same as the example above, but it's a general form then of that. And all we're just going to show then that A dot B in this case is going to be x1i plus y1j upon x2i. That changes to minus y2j. Shouldn't really be a minus there, but that's okay, it doesn't really matter. Just change it back to a plus actually. And effectively, if we did the same thing up here, remember those two middle terms are only going to cancel out. So really all it's going to be is this number times this number. So it's x1, x2 plus y1, y2. Another thing just before we go into 3D stuff, sometimes instead of writing vectors like this, we can also write vectors like this. And rather than writing the ijk thing, it can be a lot more straightforward just to write them then as column vectors. So that's 3, 4, and then that one would be 5 minus 12. And we're going to do that here for the 3D ones that are coming next. So for 3D, then the dot product, nothing kind of too cumbersome. So our A dot B is going to be our x1, x2 plus y1, y2 plus z1, z2. So again, you multiply the x's, you multiply the y's, you multiply the z's. If you wanted then your wee formula then for dot product filled in, so it's going to be x1, x2 plus y1, y2 plus z1, z2 equals magnitude of A, magnitude of B, cos theta. Example 2, find the angle between A and B. So first of all, let's work out our dot product, and we'll just do this one in column form. So it's just going to be 2, 3 minus 4 dot 1, 4, 2. So can we see that's going to be 2 plus 12 minus 8. And that means a dot product in this case then is just going to be 6. You don't need to change it into column form to do that, but it's 2 there, 2 times 1 plus 12 minus 8, and then that gives her 6, so that's our dot product. How does that help us find our angle? Well, if you put it into our dot product formula and we work out then the magnitudes then of these two, so how do we work out the magnitude then of A? That's going to be the square root of 2 squared plus 3 squared plus minus 4 squared. Calculate to get root 29. For B, it's going to be the square root of 1 squared plus 4 squared plus 2 squared, which I think then is the square root of 21. So I now have enough information to put everything into the formula. So our formula is what? Our formula is A dot B. Remember to underline them because they're vectors. Magnitude of A, magnitude of B, cos theta. A dot B, we worked it out of above. It's 6. Magnitude of A, root 29. Magnitude of B, root 21. Cos theta. Cos theta, then equals 6 over square root of 29 square root of 21. Put it into your calculator. Inverse cost, or cost to minus 1, whatever way you want to do it. The three significant figures, you end up then 75.9 degrees.